In section 6.7, we're going to be working with the inverse relations of functions. So to start here, if AB is an ordered pair of a relation, then BA would be the ordered pair of its inverse. Also keep in mind that the inverse of a function might not be a function itself. That'll become important probably later in this semester. So to start here, let's say I want to find the inverse of y equals x squared minus 1. What you want to do first is you just take your y and x and you switch them. Now what I'm going to do is solve for y. So I'll add 1 to both sides. I'll take the square root of both sides. So my inverse function would be y equals plus or minus square root of x plus 1. Let's say I have another function. Let's say I have f of x equals the square root of x minus 2. And I want to find the domain and range of f. So when I'm working with inverses, the domain and range, some interesting things happen there as well. So the domain, I just kind of look at that logically and say, okay, my radicand cannot be negative, or what's inside that square root cannot be negative. So for my domain, that would be any x value greater than or equal to 2. Okay, that would keep everything non-negative inside the radical. For my output, or my range, that square root, or that principal square root, cannot be negative. So my range would include all y values greater than or equal to 0. In part B, we'll come back to the domain and range in a second. But in part B, let's find the inverse of f, and how I would denote that in function notation is f of negative 1. So here I have f of x equals square root of x minus 2. Just for the sake of working with this to make it easier, I'm going to change that f of x to y, just because that's another way I could look at my output. Now we'll switch my variables and solve for y. So we'll square both sides, get that y by itself. Finally, I'm going to change this back into function notation. So my inverse function, f negative 1 of x, would be x squared plus 2. That's my inverse function. In part C, now I want to find my domain and range of my inverse function. So again, my inverse function is f of x equals x squared plus 2. And what you want to focus on here is your original domain and range. So in my original f of x function, my domain was x is greater than or equal to 2. My range is y is greater than or equal to 0. So even though it might not look like this would be the domain and range in the function that I see here, what I'm going to want to do for my inverse is flip my domain and range. So my new domain is x is greater than or equal to 0. My new range is y is greater than or equal to 2. The domain and range of f of x will always reverse for its inverse. So when I'm finding the domain and range of an inverse, you want to find the original domain and range first. I would definitely make a note of that because that can get kind of confusing. So now let's go all the way through a problem. I have f of x equals 1 over x minus 1. First, let's find the inverse. F negative 1 of x. Again, I'll change that f of x to y for now, just so when I'm working with the function, I want to solve for, I want to switch my variables. Now I want to solve for y. So a thing you can do is kind of switch the denominator there. Now I have y minus 1 equals 1 over x. Add 1 to both sides. My inverse function is 1 over x plus 1. Now, let's work in composition of functions. This is what we worked with a little bit in 6.6. F of negative 1 of 1. So in other words, I find the inverse of f of 1, then I plug that into my original f equation. So inverse of f of 1, I plug in here. That would be 1 over 1 plus 1, which is just 2. Now I find f of 2, so now I plug that into my original equation. So I have 1 over 2 minus 1 equals 1 over 1 equals 1. For part C, I'm flipping this. So I'm finding f of negative 1 of f of 1. So to start here, I'm finding f of 1. I plug that into my original equation. I have 1 over 1 over 1, which is 1 over 0, which is undefined. So I don't really get an answer here. And let's think about why that's the case. If I look at my original function f of x, and I ask myself, okay, what's the domain of that? The domain of this function would be all real numbers except for x equals 1, because 1 would make my denominator 0, which I can't have. So when I try to plug in 1, I don't get an answer, which is why I have to exclude values like that from my domain. So 1 is not in the domain of f of x, therefore f negative 1 of f of 1 does not exist.